is the black and the red will share the electrons. And what that means is 50% of the time the red electron will be on the left and 50% of the time will be on the right, and the same way with the black. So if you was to take a movie of this bond, and let's just say electrons had color, all right, which they don't, but if electrons had color, you would not be able to see the red and black. They would just be moving so quickly that it would be impossible to ascertain where they were. Now, if you are the left-handed side iodine, how many electrons do you think you have around yourself? So, how many electrons does it think it has around it? 8. Now, it thinks it has 8. Let's count them. 2, 4, 6, 8. How many electrons does this iodine think it has around it? Okay, so it thinks it has 8. Thinks it has 8. Now, what is the total electron count on that board? 14. Right? 2, 4, 6, 8, 10, 12, 13, 14. 14 total electrons. So, what is this iodine molecule doing? With 14 electrons, it is playing trickery with each of its atomic centers. Right? Because it should be 8 plus 8, 16, right? But since the electrons are moving so quickly that each iodine thinks that it is what atom? Xenon. So even though each iodine does not quote unquote officially fulfill its octet with its electrons only, it thinks that it does. So this iodine is isoelectronic with xenon, this one's isoelectronic with xenon, and it appears just happy snappy. So what is the word? Share. So will this red iodine come over here to the black side? Yeah. The red electron. This red electron won't. It stays completely hammered on that chlorine side. Now, do you have any questions?
So in covalent bonds, they share. Ionic, you're going to get a transfer.
So no one has any questions?
How does the nitrogen get? It's kind of like, is it ionic bond or is it covalent bond?
Ah, I'm glad she's asking the question, right? Let me kind of rephrase it, a general question. Is how do you know if a compound is ionic or covalent? All right? How do you know? Everybody in the room understands ionic, and everybody in the room understands covalent. Fine, no big deal. But if I give you random, something random, like NH3, and I'm not showing you how to draw these Lewis dot structures yet, it don't matter. If I showed you calcium bonded with chlorine, and calcium chloride, how do you know what you're dealing with? All right. So, is this a covalent bond or an ionic bond? Is this a covalent bond or an ionic bond? All right. Well, here's how you tell. I'm going to give you two answers. I'm going to give you the chemistry answer, and then I'm going to give you the answer you've probably heard in a biology classroom. Here's the chemistry answer. If you take an electronegativity difference calculation and that number is greater than 1.9, you will consider that an ionic bond. Okay, and you're like, oh my God, what the hell did you just say? Well, there's a periodic table in chapter 11 on page something another, right? 243, I think. Yeah, no, 241. If you will turn to page 241, you will find a table of electronegativity values. Okay. What is the electronegativity of hydrogen? 2.1. What's the electronegativity of nitrogen? 3.0. When you subtract those two numbers, and by the way, you have to take an absolute value. There are no negative numbers in this calculation here. This means the change in electronegativity. All right? We are answering the question about this bond right here where my finger is it ionic or is it covalent? So what is 2.1 minus 3? Don't everybody answer at once.
0.9.
0.9. Is that less than 1.9 or greater than? It's a covalent bond. So let me write down how you know. If it's less than 1.9, it's covalent. If it's greater than 1.9, it is ionic. And that's how you know. Let's look at our calcium chloride example. What does calcium electronegativity? What? 1? What's chlorine's? 3. Is it 3 or 3.5? 3.0. Okay. Now, if you subtract those two numbers, take its absolute value, what do you get? 2. So what type of a bond is calcium chloride? Ionic. Okay, that's your chemistry answer. Okay. You've got an electronegativity scale. I don't know where it'll go. I guess up to around 3.5-ish to 0. This is the change in electronegativity. The cutoff point is at 1.9. Everything less than that is covalent. Everything greater than that is ionic.
Even 0?
If it's 0, perfectly covalent. Perfect sharing. Take a look at this one. What's this one right here?
0.
0, right? I mean, it doesn't matter what this electronegativity is or what that electronegativity is. If you subtract them, you're going to get 0, right? This is a perfect ionic bond where the electrons are completely shared equally. Did I say ionic? Yeah. Covalent bond where they are shared equally. All right. Now look at this right here. Is this an equal sharing? No. Where would the electron cloud generally try to lean toward? The nitrogen or the hydrogen? Nitrogen. And they call that perturbed. The electron cloud would kind of be built up a little bit more toward the nitrogen than the hydrogen. Which means that if you're doing statistics, I told you here you draw a line down the center of this molecule. It's a 50-50 shot. Why? The electronegativity difference is 0. If you draw a line down the center of this bond, is it a 50-50 shot? No. I mean, who knows the statistics? All right. It may be a 70-30. All right. But it will be mainly sucked